Hello, today I'm going to show you how Amazon Web Services and Alexa voice service can help modern labs resolve some of their current challenges. My name is Roland Lefranc. I am a Senior Solutions Architect in the Amazon AVS team. So what are those challenges? One challenge is the separation in the lab between the traditional web space and the computational space. They are typically siloed and they don't allow frictionless data flow. Another challenge is the inefficiencies inherent with traditional disconnected instruments. Using robotic automation and IoT technologies, these instruments can become more integrated to a data flow and more efficient, optimizing the workflow to better utilize data-driven techniques. The last challenge, one of the last challenges, is about the data lifecycle management. The analysis of the data acquired by these instruments is often manual, and this leads to integration challenges. Our customers must be able to combine data, quickly derive cohorts, and conduct analysis. So how does AWS help with these challenges? Well, AWS allows you to focus on your innovation in your areas of expertise by doing the undifferentiated heavy lifting associated with solutions development. We provide scalable, secure, compliant, and cost-efficient infrastructure so you can focus on your unique use case challenges. A little bit more details about AWS now. AWS services can be used to create end-to-end architecture to manage the data across the lab. The three basic parts of the pipeline are data ingestion for the first part. AWS offers a set of managed services that help you get or put data from your IoT devices. In this case, your IoT devices are your connected medical instruments. So for example, Amazon Kinesis allows capture multiple streams simultaneously from different sources in real time. The second stage is how you process and store data. Again, AWS has a set of managed services on how you do cost-effective storage, how you create data lakes, data catalogs, how you normalize and transform data into formats that are further usable for analysis. So for example, AWS S3 or AWS Data Lake. And the last stage is the data analysis stage. AWS has a set of services that lets you do analysis, queries, machine learning, generate insights from your data, and deliver these insights to your users. For example, in the healthcare industry, Comprehend Medical or Amazon SageMaker if you want to build your workflow yourself. From a compliance perspective, AWS has over 50 global compliance certifications and over 110 HIPAA eligible services. So you can use them in a healthcare environment. Finally, about the services, all the services run in a security environment that has been built for the most demanding industries. It meets healthcare and life science use case requirements. In addition, you can integrate in your products additional Amazon services, for example, Alexa. Voice is a natural interface that can help resolve some of the challenges that labs encounter today, like be able to operate an instrument when hands are busy just by voice, and avoid cross-contamination, or make complex tasks easier because in many cases the voice command is easier to remember than the menu command or the GUI command on the instrument. And also leverage the power of Alexa as a general voice assistant always available. So the typical process when you integrate Alexa into your device, goes through multiple steps. The first step is that you develop your device. And for this, we offer multiple options. One of the options is you just do it yourself. So you take the AVS SDK that we publish as open source on GitHub. And then you integrate this SDK into the firmware of your instrument, so it becomes, Alexa enabled, Alexa built-in. The other option is you don't want to do this work yourself, and so you hire a system integrator that Amazon has qualified. We have qualified a number of them So they do the work for you on your instrument. And then there's also an option where you just buy a AVS module that has been also qualified by Amazon, and you integrate this module ready to be used in your instrument so that you just get the Alexa functionality right away. So the timeline of this integration is typically between 3 months and 12 months, depending on those options and also the amount of effort that you put in the project. Then you have the ability to optionally add custom logic to your instrument through the development of an Alexa skill. So for example, if you want to support extra utterances, like on a medical instrument, you would say, I want to support Alexa open the tray, Alexa close the tray. Then it is doable through the addition of the logic appropriate to that in the instrument and in the Alexa skill. In this case that we're discussing today, Thermo Fisher made the choice to implement Alexa for Business, which is an option of Alexa where they can deploy what we call private skills, and those private skills are available only on their instrument. And finally, you have the Alexa functionality of your device tested, so it can use the Alexa built-in badge for marketing purposes. These tests ensure Alexa devices keep the quality bar high. We worked with Thermo Fisher to get the Alexa voice service integrated in their Quant Studio instrument to voice enable it. The next speaker is Sean Bowman, VP IT Applications and Connectivity at Thermo Fisher Scientific. He will give his perspective on how AWS and AVS help their company innovate. Sean, please.
Thanks, Roland. I'm Sean Bowman. As Roland said, I'm the Vice President of IT Applications and Connectivity for Thermo Fisher Scientific. Thermo Fisher is the world leader in serving science with annual revenues exceeding $25 billion. We provide innovative technology solutions across scientific verticals, pharmaceutical services, and purchasing convenience. I've been with Thermo Fisher for over 20 years, having roles in security, risk management, and various aspects of architecture and software product development. In my current role, I'm responsible for our connectivity strategy and platform development that supports our digital products. Amazon, AWS, is a trusted partner, not just a service provider for us. They've been with us there every step of our journey in the development of our SaaS applications and our IoT product development journey. The pace of innovation at AWS is staggering, and the adoption of AWS capabilities has helped us accelerate our product development and reduce our overall time to market. I'm very excited to be part of this event today. The Alexa voice service will fundamentally change the scientist customer experience in dramatic ways. Everything from operating a lab device hands-free to overall lab planning and beyond. Next slide, please. For our customers, it's all about process improvement. Our customers want to optimize their processes, eliminate errors, and ensure their intellectual property is protected. When customers are evaluating lab solutions, they're looking for simple, reliable infrastructure, which is easy to integrate. They want to be unleashed from the lab, but not at the expense of security. They want to use innovative modern technologies and approaches that'll support their digital transformation, and they expect productivity savings through increased visibility to their process, guaranteed equipment and consumable availability, and guided workflows that are end-to-end auditable. Next slide, please. As a response to our customer needs, we developed Connect. Connect is Thermo Fisher's platform to provide software as a service scientific capabilities, including instrument integrations, monitoring and control, configuration, data storage, and analytics applications. The platform is architected in microservices and delivered to customers in a single multi-tenant environment such that it meets ISO compliance and HIPAA as well. AWS services provide us with agility and capabilities to deliver scale and make sure that it's compliant. It allows us to evolve our architecture over time and to meet our evolving customer demands. Connect's features and functionality are organized to address customers' needs to acquire, organize, and analyze data to provide scientific results. Device Connect, which we're seeing pictured here, is our IoT platform as part of our broader Connect SaaS platform. It leverages the AWS IoT core capabilities to manage communications and state with our connected instruments. Communications are handled through both MQTT and RESTful interfaces, and we segment our MQTT messages into topics for specific purposes such as telemetry and experiment data processing. We use IoT rules to enrich the data and direct it to the appropriate downstream service. Data is queued for ingestion using Amazon Kinesis, and we use the IoT shadow to pass command execution requests and maintain state between Device Connect services and our deployed instruments. We developed a series of microservices to handle the specific business logic for our instruments, such as remote command execution, telemetry processing, and access to our data management platform services. Telemetry data and experiment files are persisted in S3, and we leverage DynamoDB as the database of choice for our microservices. Instrument status, remote commands, and analytics capabilities are all accessible through web and mobile devices using single page or native applications. A customer can also access all our Connect features directly from the instrument GUI interface, including login, establishing authorized user context, browsing and downloading protocols, and uploading experiment raw data. The PCR team, led by Hardeep, who we're going to introduce next here, drove an initiative to enhance our user experience through the use of Alexa voice service. Our platform team developed microservices for handling integration with AVS, which can now be leveraged across other instrument families in Thermo Fisher. The service handles device lifecycle with AVS and Alexa for Business, including registration, deregistration, profile management like creating a room, adding a device, and associating skill groups. You can learn more about Connect on our website, thermofisher.com/connect. And I'd like to introduce now Hardeep Sangha. He's going to take us through the details of our Alexa built-in QPCR instruments.
All right. Hello, everybody. My name is Hardeep. I am a senior manager within the Genetic Sciences Division for Thermo Fisher Scientific. I joined Thermo Fisher about 16 years ago, and during this time, I've had different kind of roles ranging from software development, architecting our applications, technically leading applications, leading instrument-related projects. And over the last about 7 years, we've transitioned and focused into this cloud ecosystem. So since then, we have leveraged the AWS ecosystem and built scientific applications which let you do primary analysis, do secondary analysis, tertiary analysis for the instrument data. Not only that, you can actually set up your entire run plan within those applications. You can monitor your applications from there. You could monitor the instrument runs as the data flows out of those instruments as well. So next slide, please. Okay, so I think this is sort of the gist of the talk. Both Roland and Sean have talked about the capability of our QPCR QuantStudio 6 and 7 Pro instrument. So the idea was to give customers this hands-free experience, a capability that lets you walk to the instrument, log in with Face, have smart consumables that already have run plan stored on with RFID tags on it, but then another interface to interact with the instrument. And what better interface than a voice-based interface, right? Voice-based interfaces are so universal these days. You have, even if I look at my home, we have devices like our thermostats can be controlled by voice. My TV remote is voice enabled. Even my kids, they have light switches and they have an Alexa app. They can essentially talk to their light switch and turn it on and off. So we felt that the next ease to bring to the scientific world through this instrumentation is let's introduce another way customers can interact with our instruments. And that's why we went into this journey of bringing the voice ecosystem on QuantStudio Pro. So imagine now the QuantStudio 6 and 7 Pro instruments have this ability where you can not only use our private skills, which you can use to navigate through deep embedded user interface, but you could do all the general capabilities that are available within the Alexa system. You have an assistant in the lab which lets you set up timers. It lets you set up reminders. You're busy experimenting and you forget about how long you need to incubate something. Rather than writing on a piece of paper to remind you, there's an assistant that lets you know. With the current COVID-19 unfortunate situation, the contamination is another big piece that comes in here. We have this instrument which literally you don't really have to touch it. You don't have to touch the user interface to make it open the drawer where you need to put the plates and start a run. If you follow a predefined protocol, and if you're ordering our smart plates, the smart consumables, you can just walk to the instrument, log in with Face, give it a voice command to open the drawer, insert a plate, and off you go. So this is our idea and where we want to take the scientific instrumentation to. Next slide, please. So how did we start on this journey? This is the timeline at a very high level. So within our genetic sciences division, we have this culture of Innovation Day. Every year, we sort of showcase the innovations we are pursuing. Those innovations could be software related, could be hardware related, science, chemistry. So one of the innovation we talked about September 2018 was, what if you could interact with an instrument with voice? Be mindful at that point, Alexa for Business wasn't available for OEM devices. It was only available for Amazon devices. So we showcased this whole capability with AVS, and it was well appreciated. We followed it up with a voice of customer session, and again, it was keen interest in that. So from that point on, we decided, this is something we want to pursue seriously and offer it in our flagship product. So we started with an architectural review in October timeframe. This is when we got together with lead architects from Amazon's Alexa for Business team, the Alexa voice service team, the solutions architects, the architects from our platform team, and from within the genetic sciences team. So once we nailed down the architecture, we kind of started rolling the ball. I think November, December timeframe is when we actually got access to Amazon's Wakeword engine. Some of our single board computers were registered in the Alexa for Business beta access portal. January timeframe is when we build this abstraction layer using Voice Connect platform services over the Alexa for Business registration. Fast forward a couple months, we ended up with the whole instrument essentially ready. The user interface is ready, the voice service is ready, our platform services are all enabled, and we had few customers try it out in April timeframe. And beyond April is the certification process. So we again worked with Amazon to pre-certify the box internally and then hand it over to Amazon for the final certification. Next slide, please. Okay, so I'll take a few minutes on this slide. This is essentially the core of our instrument and how the whole voice system works. So on the left side, we have the sort of a block diagram highlighting how the instrument internals are in terms of software. So the operating system is a hybrid operating system between Debian and Linux. So the Linux kernel comes from the Android x86 AOSP project. And then we make some modifications to the kernel, like changes to the IPC, the hardware abstraction layer, some changes to the media services, and so forth. And on top of that, if you keep going up, there's the standard third-party libraries related to Python, C++, and the Android VM itself. So the green pieces are which we have developed within Thermo Fisher, and then the blue ones are which we've got from Amazon. So the data collection green piece is essentially the heart of the whole system, right? That's where the customer sees on the touch screen. That's where they interact with the instrument. It controls the instrument. That's where you would see the run status. You could plan your runs. You would see the amplification plots coming out of as the run's progressing. And left side, there's a couple other services, the Thermo Fisher Connect and Instrument Server. So Thermo Fisher Connect is our connectivity SDK that essentially connects this instrument to the outside world. It's the piece that connects us to IoT Gateway, to S3-based storage, to our own Thermo Fisher Connect services like Data Connect, Voice Connect, and so forth. Instrument Server is our abstraction over the sub-assemblies we have in this instrument. So Instrument Server is responsible for sort of conducting or orchestrating the communication between those sub-assemblies and the data collection system. It also serves as a message broker for us, which is key for this voice-based implementation and any service that needs to communicate between the Debian space and the Android space. The blue pieces, so AVS Client SDK, we've got from Amazon, we've used as is. The Wakewood engine, we tried some third-party engine and switched to Amazon's Wakewood engine, got much better performance. The AVS application actually is a sample application, which is an extremely good starting point for us. So we took that application and modified that to our needs for us to get a much faster time to market sort of experience. Now, if you transition to the right side, it talks about the interactions. So if a user walks to the instrument and says, you know, Alexa, and once the wake word is registered with the Alexa system, it sort of starts streaming audio. And remember, I said that the user experience is important and it's part of the certification process. So the user experience is very similar to what you would notice on an Echo show. So the main user interface sort of fades and you see a blue bar on top of the instrument, signifying that it is now actively streaming audio to the Alexa cloud ecosystem. So in order to further safeguard our customer needs, we have a physical, we have a touch-based mute button that's available on each screen. So if a user opts to, they can mute that, and which underneath stops the AVS service. Not only that, we also have a proximity sensor built on the instrument. So if you're about 2 feet away from the instrument will stop the audio service and no communication will happen to the Alexa cloud. So coming back, so once Alexa recognizes the wake word and the audio starts streaming to Alexa cloud, that's where the Amazon's machine learning algorithms kick in. So the first aspect is the automatic speech recognition. We takes this audio stream, converts it to text, and then it sort of ranks it, saying that these are the most 4 or 5 probable intents it can match to. And it passes the highest confidence one, passes on to the natural language understanding model. And from there, it's essentially which skill can satisfy that particular intent. And since Roland talked about it, since we're using Alexa for Business, we've developed a private skill, which is not available on commercial Amazon devices. So our private pro skill gets invoked. And once that skill is invoked, within that, we call a few of our internal Thermo Fisher services. Services like Voice Connect and Device Connect, which kind of give us more information about that interaction, like what's the user that's associated with that particular invocation, what's the device ID associated with that. And using that information, we channel that command onto the IoT device shadow. So once that command is available on the IoT device shadow, the Thermo Fisher Connect SDK is registered on the Delta topic for that device shadow. So once a command is there and the Thermo Fisher Connect SDK picks that command on the Delta topic, it uses the instrument server message broker capabilities to pass that command onto the data collection. And the data collection, once receives the command, it kind of reacts to it. So for instance, if you've asked it to open the door, that's how it'll get that open door command and react to it and physically open the door for you. So this, I hope, gives you an overview of how this whole ecosystem is built. Next slide, please. I think I briefly referred to this earlier. It wouldn't have been possible without Amazon's help here. It extremely helped us. The time to market is the biggest impact I see, because we were able to reuse a lot of capabilities from the ABS SDK, the Wake-Word engine, the sample application as a starting point. And then not only that, having a regular cadence. So we used to meet on a weekly basis and then go over the architectural decisions we are making, any issues we're encountering, how do we speed up that process. So that very engaging and timely support kind of helped us get this product out on time and with quality. Next slide, please.
Quant Studio 6 and 7 Pro real-time PCR systems, intuitive software, straightforward interface, and hands-free capability come together to integrate QPCR into a seamless lab workflow. Log in with facial authentication and get started without removing your gloves. Use voice commands to easily start a run hands-free, avoiding potential contamination.
Open door.
Automate data entry with TACMan RFID plates to eliminate the need for manual input and reduce human error. Take a step forward into smarter science with innovations inspired by you.
I hope you enjoyed the video, the short introduction for all the smart capabilities the instrument has. As with any fun project, there's always lessons at the end of the project, and I think our core expertise is building scientific instruments, and as I think Roland referred to it, we went in the direction of building our own front-end system. Building a front-end audio front-end system on an inherently noisy instrument can be quite challenging. Going down, trying to figure out which is the right microphone array to pick, what's the right position to place, what's the right chipset, what kind of onboard algorithms you want on that chipset. All those decisions are critical. So you have to keep that in mind when you take this journey. The second aspect is when you're designing the language model or the speech model, you have to be very mindful about the utterances, the crosstalk between those utterances. So it would be very beneficial if you provide users with a whole bunch of alternative ways of invoking a certain command. For instance, if like a basic command like open the drawer could be open the door now, or please open the door. Giving all those options makes the experience better, and it makes it better and also in a way that it's very intuitive for the users to use the system rather than having to memorize few key commands if it becomes more conversational. So that's important. I think at the end of the year, we did get a Life Sciences Innovation Award for this product, which kind of showcases the capability and the innovations we have done for this particular device. I think I talked about these Face ID. Apple introduced Face in iPhones, and it changed the whole world and changed the whole market. And now with this instrument, we have introduced Face ID truly in a scientific instrument. We've introduced voice, and I believe we are the first ones to do that in the life sciences space. Again, we've given our users that ease and that experience to have a lab assistant sitting right next to them within their instrument. In terms of usage, we've noticed primarily customers are using to navigate to deep embedded menus items. They're using it for they're also using it for a bunch of Alexa public skills. So having all of that, your private scales and all the Alexa capabilities, it's a very powerful combination. And again, this is our first step kind of into this in direction, and we are constantly improving and building on top of that. One feedback we've got from our customers is that can we get rid of the invocation name? So we are currently working with Amazon how to figure out ways to optimize that, how we can get to invocation-free skill set. So that's where we are at. Thank you very much.
So thank you, Sean, and thank you, Hardeep, for being here today, to present this talk with us. I would like to thank you very much also for the quality of the collaboration that we have, over the past 2 years, and the quality of the product that you have put on the market, integrating the Amazon technologies. So again, thank you, and I also want to thank, all the watchers of this video for your attention.